let us deal with a very interesting problem that can come up in examinations. For example, you are given that an alpha helix structure, alpha helix, if the length of the alpha helix is, let us say, 45 Armstrong is the length of the alpha helix. We want to find out how many amino acids are present. So therefore, how many amino acids are present, or how many turns. So these are the 2 points that we are going to discuss now. So assume that if the length is 45 Armstrong, so we know that if the distance between 2 amino acid, the distance between 2 amino acid is 1.5 Armstrong. If it is 1.5 Armstrong, so therefore 45 Armstrong divided by 1.5 Armstrong, that will give us a value of 30. So therefore, you are going to have 30 amino acids in this 45 Armstrong. So how many turns can you make with the 30 amino acids? So 30 divided by 3.6, that is roughly about 8.3 turns can be made with the 45 Armstrong length. So it will give us a clue about in the transmembrane structure. In the plasma membrane, what will be the roughly the length of an alpha helical structure. So this is how we calculate. Another interesting problem can be, you are given a number of amino acids. Let's say that we have 50 amino acids. What can be the axial length? What will be the length of the alpha helical structure? So how do we calculate this? This is also very easy to calculate. So therefore you have 50 amino acids, and in the 50 amino acids, you know that in every turn you need 3.6 amino acids. So therefore, how many turns can be made? So therefore, if the number of turns is equal to 50 divided by 3.6, this is equal to 13.8. So therefore, you can have 13.8 turns by using 50 amino acids. Okay, so if you can have 13.8 turns, you know that if the pitch of one ring is 5.4 Armstrong is the pitch. So therefore, what will be the total length it will take up? That is 13.8 into 5.4, that is equal to 75 Armstrong. So therefore, once you know the number of amino acids, you are also able to calculate the length of the axial length you are able to calculate. So you know that in a membrane, so this is the alpha helical structure. This alpha helical structure will be 75 Armstrong long. So these are some of the applications of knowing all these fundamental values in calculating in the structure of alpha helix. Another interesting problem can be to solve how many hydrogen bonds are present in an alpha helical backbone. How to solve this problem? So let us assume we have an alpha helical structure which is made up of 15 amino acids. So let us write the number, first one, second, third, fourth, fifth, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15 amino acids. So 15 amino acids are arranged. We want to know how many hydrogen bonds can be present. So we know that every amino acid can have 2 hydrogen bonds. So since there are 15 amino acids, there will be 15 into 2, that is equal to 30 hydrogen bonds are possible. How are these 2 hydrogen bonds possible? One with the amino nitrogen and another one with the carboxyl end of the amino acid. So therefore we have 30 hydrogen bonds. But we need to do a correction. What is the correction? We know that if the first 4 amino acids and the last 4 amino acids at the C terminus can have only one hydrogen bond in this particular structure. So therefore 4 plus 4, that is equal to an 8 hydrogen bonds. We must minus it, which is equal to 22 hydrogen bonds. We need to make one more correction. What is the correction? When we were counting the hydrogen bonds, we counted 2 per amino acid. That is one for the donor, another one for the acceptor. So therefore, we need to divide this total number of hydrogen bonds by 2. That will give you 11 hydrogen bonds. In other words, a helical structure which is made up of 11 amino acids will have, made up of 15 amino acids will have 11 hydrogen bonds. This is how we calculate it. We can check this diagrammatically. How do we check? So let us construct, let us form the hydrogen bonds. So we know that every amino acid can form 2 hydrogen bonds. So amino acid number 1, if the carboxyl end will form a hydrogen bond with I plus 4. It will form a hydrogen bond. So therefore, the first one will form a hydrogen bond with the 5th amino acid. This carboxyl end forming a hydrogen bond with the amino terminus of this 5th amino acid. If the second will form with the 6, if the third will form with the 7, and the 4th will form with the 8th amino acid. Now, what about in the 5th one? If the 5th amino acid will form a bond with the 9, 6th will form with the 10, 7th will form with 11, 8th will form with 12, and 9 will form with 13, 10 will form with 14, and 11 will form with 15. So this is how the hydrogen bonds will be formed based on this principle which we have learned. Now count the hydrogen bonds. So here is the first one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 hydrogen bonds. That is matching with what we have calculated. So this is how we prove the number of hydrogen bonds that are existing in any short polypeptide chain by using calculation as well as by using diagrammatic method. I am sure that you have enjoyed going through these videos. Keep subscribing and keep watching.